Hello, everybody. Welcome, and I hope that you have been enjoying this morning with the SciTech presentation, and you will enjoy the rest of the day and all the amazing presentations that we have prepared for you. In the next 15 minutes, I'm going to tell you an exciting topic, how you can combine two seemingly unrelated concepts, one being a vault, and the second one being a secret engine to solve a pretty nasty problem, which is referred to as a secret sprawl. Before we dive into this, let's very quickly touch the base where the secret sprawl comes from. In fact, all IT operations, all organizations operate a sort of long-term credentials that need to be properly secured and kept under lock and key. But the reality is that it is almost never the case, and eventually these long-term credentials get copied and what is most importantly, retained in the places that are weakly secured, that can result in the compromised access to the production and with, depending on what your organization is dealing with, to a major damages. Before going further, let me quickly introduce myself. My name is Alex. I'm 21 years old and I have 22 years of experience. Just don't ask me how it's possible. And it so happens that all these years I have been working with the projects that were dealing with encryption, or I have been working for the organizations that were obsessed with the confidentiality. And of course, it has left a mark on me. And I'm here to tell you that these days, with the proliferation of the cloud tech, you are the key to make sure that your workspace and your organization is secured and resilient against the unintended secret sprawl. You may think that it will not affect you, but just consider this. Maybe you are in the middle of it, and let me show to you how it happens. It all begins one day when a junior coder, let's call her Monica, joins your team, and she starts working on the amazing API design. And she will be using an Orange tool of fun called Postman. I'm pretty sure everybody who works with the APIs knows this tool or has been exposed to this tool in one shape or another. And as far as her developments sit on her laptop, it's all fine. But then eventually, that API needs to be promoted to test environment or to production environment, where the security and authentication becomes a necessity. So how will Monica solve it? Well, the internet is full with examples how to use Postman pre-request script and environment variables. What's the big deal about that? This green button of evil. Because what it does, it actually copies the data from Postman collection, which Monica has on her laptop, to Postman Cloud. And the reality is that not everybody is aware about it. And for a security-minded person like myself, it makes me genuinely scared because I think in terms of the weaknesses. How is this account is secured? Because if long-term credentials are stored in the environment and available in the Postman Cloud, then the attacker can able to plot the attack. It's a far-fetched scenario, maybe, but if it materializes, it's almost impossible to diagnose, and it can go for a long time, and that's why it is actually dangerous. The reason why I can talk to you about today is I want you to introduce to the exciting tool, which is called vaultproject.io from HashiCorp. It is an exciting tool, and it's a good excuse for you guys to learn a Go programming language. And I'm going to tell you in a second how you're going to do that. So how does HashiCorp and the Vault project help to stop the sprawl? It helps building sprawl-aware Monicas who begin her daily work by installing Vault and saving all long-term credentials into Vault so that they're persisted and she never touches them. Then Monica understands the value of frequent authentication using Vault login and storing quickly expiring access tokens so that she places these tokens into environment rather than the long-term credentials themselves. And she programs the scripts to retrieve the authentication from Vault, which is great. But Monica is smart and she will go a step further. She will say, well, if my company is using specific authentication methods, maybe I can also build the Vault engine that will wrap these credentials so that they are not expressed in the pre-request scripts. Where does it bring to us? It brings to us to the point that with the Vault in place, the attacker can still get to the Postman collections in the Postman Cloud if it is weakly authenticated, but he is not able to do anything with it. And why this would happen? It would happen because in this scenario, the authentication method is not disclosed, and all authentication, in this case, would be retrieved from the local host, which will be essentially attacker's grave. You have Postman, you have what seems like credentials, but you cannot really do much except one thing, and that is admire Monica's professionalism in safekeeping and guarding her company from getting an inadvertent exposure. If I manage to sell you on the benefits of Vault and a Vault engine, waste no time, go to the vaultproject.io and check these two tutorials that really will help you to get started. And as I have mentioned to you, HashiCorp not only provides a very well architected product, it's pretty much a Go language-based ecosystem. So if you choose to adopt HashiCorp Vault, and if you choose to write your own secret engine to authenticate and to encapsulate authentication process that is specific to your company, this is your good excuse to don't go. It would be too great to leave it here, but there are a few things that I want to mention to you. Be aware that whenever you will try to pitch the idea to include Go in the daily working of your team, you get to hear a no from your manager, from your PO, and from products. And there will be many reasons for it that you get to hear. So before you pitch, think really well. Do you really need a secret engine? Maybe you can solve the credential sprawl in your organization, in your context, in a bit different way. Seriously, we're here engineers first. A pro tip though, there is a good way to pitch the need for it, and this is to compare the risk of the exposure with the consequence of the exposure. In my example, what I have evaluated, it landed roughly here. So although my team is fairly experienced, but we manage credentials that of such importance that we actually have to do something. We have to be proactively on the lookout how to mitigate and how to reduce the chances of this problem. There is another thing that I will tell you is that the Learn and Go and Study in Vault is actually bigger than it might appear. And this is roughly the breakdown of the effort that I've spent myself from knowing no Go and no Vault to writing my own secret engine. Just to give you the idea, it took me about 3 weeks on a calendar to have a fully functioning secret engine. I will share with you 3 gotchas, specifically intended for Java developers or maybe Node developers who have never used Go language before. What to watch out, because if you aren't aware about these specifics about the Go, it may cost you an awful amount of time. The first one is how Go parses JSON. There are 2 things that you really need to be aware here. The first one is that the type structures have to be have to start with the uppercase. It's actually hard requirement. It's counterintuitive for Java developers. We're used to camel case. And the second one is that Go actually introduces pointers. And in some cases, you may want to declare a pointer to primitive types. It's something that we sort of forgotten about Java, because Java does this all under the hood for us, and the way Go language manages memory makes this a requirement to do. The second gotcha, which unfortunately isn't explained very well in the tutorials that I have mentioned to you, is actually how to retrieve data and how to persist the data, because apparently it seems like everybody in Go community knows it. So the first step is when you actually parse in the data that the user is persisting within the Go encrypted storage. Actually, it turns out it works well if you have 2 steps. The first step is you check whether the parameter is actually passed. And the second one is this funny syntax with dot parentheses is actually forced typecasting. Do this, and it's going to be OK. Once again, it's actually straightforward what it is if you know where to look. Now, to save things, you actually need to wrap your data structure into the storage entity JSON. Very well explained in tutorials as far well as I can tell from my memory. So another one, guys, take out. Remember this storage entity JSON will actually make sure that your data is persisted in encrypted storage. Reading it, it's actually a three-step process. First one is you need to get. Then the second one is you have to initialize the structure. We in a Java world, we just don't do it because Java does it under the hood. And the third one is you decode what Vault has retrieved out of the secret storage. So it all these two gotchas have to do with how Go language manages memory, and once you get a hand of it, it starts making perfect sense. But for Java developer, it's really confusing what has to be done. And the third one is what is the lifetime of the secret that you expose. And essentially, if you look at the decision tree, there are actually 2 times that Go codes, but there are 3 situations. And the third situation, which is sort of in the middle, is situation with effectively irrevocable credentials. For those in the audience who are familiar with, for example, OAuth protocol, an effectively irrevocable credential is an OAuth token if authorization server would not provide a means of revoking it. So let's say the token is there. Once it's issued, it can only expire. What Vault tries to do, he tries to make sure that either you return data or you return lease and you supply the means of expiring it. So for this in-between state, you really need to think, do you want to use Vault agent caching? It is an advanced topic in itself, or not, because this will greatly depend how you will code. I will briefly show you a few examples. This is the example how you can code one-time passwords and effectively irrevocable and non-cacheable examples. It's just a map, in fact, that you return and it's not going to be cached. For the secrets that are revocable or effectively revocable and cacheable, so only if you need caching, then you need to make use of the lease API that's provided by HashiCorp internals, and you need to actually to supply the revocation function, which doesn't do anything. This is again something that isn't explained really well within the tutorials, and it cost me a lot of time just figuring out why, what needs to do that. Kind of last but not the least, what is the difference between lease and adjust data? So lease contains 2 sets of data, one data that the user will see, and the second one that the user will not see, and only Vault extension or revocation functions will have access to. So if you need to put something like, in this case, refresh tokens, yeah, this is where they need to be persisted. And for security reasons also, Vault gives you a lot of flexibility in controlling the time to live and the maximum time to live, how long your session will be extended and if it will be extended. Of course, I wouldn't be expecting that you will be able to do that. There is, of course, the learning that would be required for you to go and check Go documentation. Yeah, sorry about that. Maybe pick up a few books and spend the weekend reading into it. But I know that our audience likes to copy paste things. So what I've done, I have shared the secret engine that I have developed myself for my particular purposes on a GitHub. Feel free to go, copy paste, clone, and do the needful, and let me know if you find it useful. And if you don't find it useful, also let me know. I'm very curious. To close, guys, that's not a very difficult thing to do, to write secrets and learn Go for HashiCorp Vault. If I could do that within 3 weeks, you can do it as well. Unfortunately, I wouldn't be able to meet with you with a coffee. So if you have any questions about Vault, about secrets, about Go, feel free to reach out to me on my LinkedIn account or on my Cytec email address. And remember, guys, when we talk about the security, preventing incidents is always cheaper than mitigating them. Do onto security before the lack of security will do onto you.